All right. Welcome back to another episode of the Southwest Climate Podcast. As always, I'm here in a room with a table and Mike Crimmins. How you been?
Good. Real good.
Mike and I share an office wall, and I haven't seen you in 2 weeks. You been doing good, though?
Yeah, it's pre-monsoon season.
I know, right? It's
days away from the buzzer going off, the bell ringing. I don't even know what's the onset. What happens?
That's right. And if you recall last year, June 15th,
yeah, that's right.
The official start date actually became the start of the monsoon.
It was awesome.
Although we debated about whether or not that June 15th event was actually a monsoon.
Yeah.
Chances are that's not going to happen again this year. But yeah, we are just days away from the most exciting time of the Southwest, if you ask me.
It's the most wonderful time of the year.
And we're going to spend quite a bit of time doing our monsoon preseason predictions straight from the multilinear Mike Crimmins model.
The eyeball regression.
The eyeball regression.
Yes, my Wikipedia page has the eyeball regression.
Wow, we have a lot to talk about because May was interesting.
Do you remember what we talked about in the last podcast? And you and I taking bets on how many 100-degree days
That's right.
were going to happen in May?
Boy.
How many 100-degree days would happen in Tucson?
Are you asking me?
Yeah. Well, actually, do you remember what your prediction was?
My prediction was 6.
I thought I put 6.
Or maybe I put 5.
Did I put 2? I was closer.
Yeah, you were closer. Yeah, so that's a story that we have to unpack because I think the weather story of May was obviously the temperatures. 2 big things that we want to cover today are a recap of May, particularly the anomalous temperatures, which became, in my mind, one of the most astonishing months that I can remember. So we'll talk about that. Then we'll talk about the monsoon. But first, Mike, maybe you can set the stage. So what was the sort of weather scenario from like a big picture, a regional picture, like the atmospheric pattern for the month of May? Can you provide that context?
I've been telling you, I've been trying to make sense of this entire winter for months now. And went into the maps, went into the data, trolled all of the discussion boards from the different weather and climate agencies across U.S. agencies and then internationally too, to try to make some sense of what was what. The circulation pattern, as you're alluding to, that led to the anomalous conditions, we had a really active jet stream with a lot of waviness, as a technical term. And that waviness brought persistent, anomalous cold, cooler than average cold, really, cold for May anyways for the Southwest, to much of the West. I mean, just that active jet stream pattern pulling down a very wavy with broad ridges to the east up into the Arctic, and then pulling down cold air to very low latitudes through the month.
Right, because every time I looked at the weather forecast, there was some low pressure system that was moving down off the West Coast and into this area. In fact, the last couple of days has been another one as well.
The climatological non-noisy weather progression is going to be the jet stream retreating north as the northern hemisphere warms up, as the sun angle increases in here. And weather is going to be dynamically what's occurring every day with the energy imbalance. So since basically, right after Christmas in December, when we switched over into that really active weather pattern we've been talking about for months, it has continued. I expected things to start to kind of calm down and us to move into the sort of typical quieting of the storm track, or at least lifting north and putting us more in the quiescent kind of ridge building transition season that we normally see. And it just hasn't happened. I mean, we've continued to see this sort of parade of, ridge trough progression and parking troughs, so that dip to the south in the jet stream pattern across the West, which has led to really suppressing our temperatures.
It's actually quite astonishing. If you look across the West at temperature maps, basically all of Arizona for the month of May was in its coldest 10%.
Coldest 10%, with some record coldest in the far northern part of the state. And we can look across the entire West. Only the Pacific Northwest was in its above to much above, and even some small areas of record warm. But from the Dakotas all the way down into Arizona, we were looking at much below normal.
That's showing more or less the track of the jet stream. As the low pressure systems, the cool systems are moving down off the coast, it's coming.
It's a pretty complex pattern.
Yeah,
it actually doesn't make a lot of sense, because you'd end up having a really sinuous jet stream pattern, which we've actually had. We've actually had a lot of splits, and so that split would lead to some of that too, where you can actually have a ridge over the Pacific Northwest cold Canadian air coming in through the Dakotas, and then a trough actually persisting underneath the ridge in the Southwest. And that's what you've seen is a really noisy weather pattern for months now.
Yeah, it's funny. As I was starting to speak and I was looking at it,
you're like, wait,
that doesn't
make any sense.
Yeah, because one would think that the Pacific Northwest would also be cool.
Exactly. So to break it the way that we've done it, you actually have to have the sort of divergent jet pattern.
Yeah, so to put that a little bit in context, zooming in now on Tucson, one point, but this is probably emblematic of a lot of areas around the country. The average May temperature was 6 degrees Fahrenheit below average.
That's a lot.
That's a lot.
It's exactly.
But here's the thing. That's not actually a record.
Right, which is interesting, right?
It's really interesting. So it's actually, if you look at the, let's see, I have, 125 years worth of data. 2019 pulls in at fourth coolest. But as you were alluding to, the top 10 years, including 2019 is the only top 10 year in the last 40 years.
That's amazing.
Right. So,
that is amazing.
So the coolest year on record for Tucson is 1917. And, it had 7.5 degrees cooler than average. 1953 was the second coolest. 1933 was the third coolest. Then 2019. So what I think makes this even more remarkable is we're having a cool May despite record cool May despite the warming trend.
The warming trend, yeah. Is that average temperature?
That's average, yeah.
You get a slightly different story if you look at the maxes and the mins separately. So the airport record, which actually goes back to 1948, the 2019, the average high temperature, it was the second. The second coolest in the record from 48.
1953 being the coolest.
1953 being the coolest, right? And so if you switch it over to min temperatures, then the trend actually comes back into the discussion. It's going to be urban heat island impact, and then you'd expect to see some of the broader scale global warming trend.
What you're saying is the mins weren't as anomalous as the maxes were.
That's right. Yeah.
Right. So the mins were a little bit warmer. They brought up that average, which I was talking about. The point being, the mins weren't because of the such things as a urban heat island.
Yeah. And I guess also we didn't really do a lot of diagnostics on this, but the dew points there was actually precipitation in May too, which we ended up setting a daily precip record in Tucson at one point with over an inch of rain.
That's right. It was just one event.
One event right on the airport. Didn't rain in much of the rest of the town. It was kind of one of those monsoon things where I was thinking of both you and Ben as I was watching it rain on the airport gauge.
I know.
Just like, what? If this was monsoon, I would be all over this, but it wasn't. The point being is that having that humidity in here is going to end up impacting overnight temperatures too. So we're typically, down in the teens or 20s with Fahrenheit dew point temperatures in May as we dry out sort of in advance of the monsoon season. But we've just had high dew points sort of socked into the Southwest again since January. Just this connection across the Pacific and into the Southwest of the dew point. And it's continued into June. It sort of lingered into this month as too. So that's going to keep up overnight temps. But the min temps during the day, really a function of cloud cover and the circulation pattern, having that trough across the west.
If you look at the trend in the average data, it's basically 0.2 of a degree Fahrenheit per decade. And so that equals over the record, over 2 degrees Fahrenheit change. So again, I think it really puts how cool this May was in perspective. I mean, you have to go back a long time for us to be
even
close.
Yeah, anywhere close. You've got to go back into the 70s to see us even getting something in the ballpark, what we've seen with this May.
2015 was the 22nd coolest on record. It had an average temperature close to 4 degrees Fahrenheit below average.
I don't remember 20.
Yeah,
Do you remember?
Yeah.
I don't. It doesn't stand out. I mean, it would have been a really cool May in the run that we had of those previous 3 years that had been so warm.
Before we talk a little bit about what might have been causing this, I know you already talked about the wavy jet pattern, but if we think a little bit broader and what's at play to cause that wavy jet pattern, it is worth saying that it was really great.
It was one of those where in the middle of the month, toward the end of the month, I was like, it'll never be like this again.
Yeah.
And I couldn't hold on to it. I was like, oh, I have to somehow soak this up more. I can't. Oh no, it's slipping away.
No, I mean, if you look at the last 2 years, they were both close to a degree and a half above average. So, I mean, it's like 8 degrees difference this year from last year.
That's exactly, I was just looking at that data. It was 8 degrees cooler. 8 degrees for a monthly average. That's like almost out of phase of a whole season or two.
Yeah, it's amazing. So typically, this is the time of the year when the jet stream is pulling north, and weather happens, and so you do get the sort of low
weather happens.
Weather happens.
This is your bumper sticker says.
And so you do get storms in May or cool conditions. Like these dry, usually they're dry sort of low pressure systems that move by. You do get that. Mm-hmm. Has this year been, we just have seen a higher frequency than normal, or?
It's like there's no pure attribution on this. Okay, so just the point of the jet has been extremely wavy, and if you look across the whole northern hemisphere, you see some pretty strong anomalies that are corresponding with where the jet stream has parked itself, or not even parked itself.
Has it been progressive, or has it?
Yeah, no, there hasn't been. There's been periods of strong blocking, but there's also been progressive in meaning that the ridges and the troughs aren't sticking in some spots.
If you're looking at like the waves are moving across.
Yeah, you can have standing waves in the jet stream, and you can have progressive, and you can have both, and then you can have splits in the jet stream. We've had a little bit of everything, and it's kind of moved around over the last couple of months. So it hasn't been like one pattern has stuck around. It's just been a very active across the entire Pacific, from the tropics to the North Pacific. And across the U.S. has led to some really anomalous surface temperatures and surface precip based on that jet stream.
Could it also be that what the cold air that's being ferried down is just colder, or is the anomalous cool temperatures here just a function of just more frequency of the?
I think it's more frequency. I don't think it's colder air. I think it has to do with the efficiency and the frequency of the anomalies. One thing I noticed when you start to look at some of the plots of the difference from average is that the latitude where you're starting to see where you do see the anomalies is really low. You end up getting negative anomalies at very low latitudes.
Like what?
Down around us, right? Okay. I mean, for May, you can see sort of anomalous patterns in the jet stream and then corresponding changes in temperature and precip. But related to the jet stream pattern, they should be sort of progressing north, right, in sort of transition. But we've continued to see this very anomalous wavy jet stream across the whole globe from winter to spring to right into this month.
All right, so if we look at like potential mechanisms that would cause that, what can we point to? Can we talk about, the tropical Pacific Ocean and El Nino may have its grip. There may be something there. There could be this Madden-Julian oscillation, which we've talked about before. Anything about like the northern temperatures and the sea ice. What could we cite that might explain this sort of wavy pattern? Or are you...
Yes.
Oh.
No, everything that you put on the table is possibly a culprit. And so it's been interesting to watch a lot of the sort of operational forecasting discussions and blogs and everything like that. And nobody's really bit on any one cause here. And the National Climatic Data Center, which is now, I think, the National Center for Environmental Information, NCEI, writes up a State of the Climate report and does a synoptic discussion every month. And the one for May isn't out yet, but the one for April was out. And in looking through that, it's interesting. They do this whole sort of attribution exercise from respect to broader synoptic patterns. And El Nino is present, has been present in very weak fashion. Again, the sea surface temperature patterns are there. The atmosphere has actually responded finally to those sea surface temperature patterns, but in sort of a weak way. The Madden-Julian oscillation has been very active over the last couple of months. And it has actually moved, parked, constructively interfered with El Nino's circulation pattern, destructively interfered with it, sort of took it out of circulation, took it out of importance. And so there's been just a lot of strong forcing in the tropics. Some have suggested that higher latitude patterns, related to high latitude warming and sea ice extent could be at play this year. So
warming there would reduce the temperature gradient between the poles and the tropics, right? And therefore, exert less of a pull on the jet stream.
Maybe. I think it's more complicated. I think some of the mechanism, because it's all very local, right? Mm-hmm. And so there's local gradients, and then there's teleconnections from the tropics up to the Arctic. And so then you can end up seeing changes in the Arctic that then translate back down to the tropics at much longer timescales. So, earlier in the season, I think it's less been the case later in the spring, that a split or displacement of the upper level polar vortex, ends up influencing the jet stream pattern weeks to maybe months later. So many moving parts. I think we've said that over the last couple of months. A lot of moving parts, no pure attribution. If you look back at some of the correlation patterns, like it was interesting, we kind of talked about 1953. 1953 was a weak El Nino year. Ended up being a very cool May. It was the coolest May on record. Is that causation? It's correlation at that point that we both had weak El Nino events. The correlation patterns suggest during weak El Nino, you can see this trophiness across the East Pacific and across the West. There's something to it, at least in the historical data. But I do think it's been at play with a lot of other moving parts this year. And so the pure attribution isn't probably there.
Right. So the El Nino link that you mentioned, I looked at the number of days in Tucson above 95 going back through 1950. And the Mays with few days above 95 were actually El Nino years.
Yeah, it's interesting.
And so this year I think had one or two. You look back at 2015, 2016, and it was just 6. You look back last year and it was close to, it was 18. At least in the statistics, there does seem to be some El Nino related effects.
Yeah, and I think, dynamically you can force an extension of the jet stream across the Pacific. I think it's just another little mechanism to, I think, create some instability in the jet and the activity that extends into the East Pacific. And it doesn't do it every year. It doesn't do it consistently. That's right. So 2015 was the Godzilla event coming online. And I kind of do remember that it ended up being a fairly mild May. Yeah.
Has it been officially dubbed the Godzilla?
I think it has actually been. Yeah. It's
just
a named El Nino event now. They retired the name.
I think it's just a lack of creativity.
Yeah. I think we all had a lack of creativity back then.
They're better names than some of them.
That's really right. We'll have to name the next
Snowpocalypse
one.
and
Yes, right.
Okay, a couple other statistics of the May. You predicted just 2 days in May of 100 degrees.
Yeah.
Or warmer. That's pretty good.
I got to give you kudos
for that.
I think I had a gut feeling.
I think the climatology is 5. It's not all that unusual.
But it's 0 in the last 10 years.
2015, 2016, I think had 0 too.
Did they really?
Yeah.
No kidding.
Yeah. But the first day for Tucson of 100 degrees Fahrenheit or greater was, so that actually came in at the 11th latest on record. And so again, this is just another sort of interesting part of describing how really cool it was, even into early June.
I think we kept waiting for the other shoe to drop, and it did. It dropped this week.
So the climatology for the number of days for the number of days for temperatures greater than 100 degrees is 20 in Tucson, and basically we would have to get a nonstop stretch of warm weather for that to be, which has happened. What do you think?
I don't think we're going to do it. When we start talking about sort of the outlook here, I think we can dispel some of those fears. I just want to put a point on too for May of how wet it was to the north here. Across Arizona and New Mexico, northern Arizona, based on some of our gridded climate data, ended up having its wettest May on record and also its coldest May on record. This would be far sort of northern Mojave County and parts of Coconino, and the record standing back to 1895. And
that's not just a function of that one event that hit southern Arizona,
it was
right? There was a number of storms that
persistent storm track of just clipping the northern part of Arizona.
Can you think of a period, let's say a month long, not an event, but a month or a season that was as unique as May was? I've got 2, but can you what comes to your mind?
Like equivalent temperature wise?
No,
just like something.
Because I think that this May could be one of the more astonishing periods, at least since I've been paying attention.
It was incredible. I had family out from Michigan and was warning them that it might be hot and we didn't have the air conditioning on yet and that kind of stuff. And we ended up wearing sweatshirts the whole time. It was classic sort of Michigan spring weather in May. So I didn't know where it was. I didn't know what time of the year it was. All I knew is that the sun kept getting higher every day and it didn't get any warmer. I've been out of sorts with the weather here up until this week where like it finally got up to like I think 105 or so. And now it's like, oh yeah, I forgot. This is what this place is like. But as far as sort of equivalent periods, I'm thinking back to June or two ago when we ended up, pushing 110, 112 here, which had really stood out to me of like, oh, this is what Tucson has to offer on the high side.
Yeah, right around.
I had no idea what it had to offer on the low side.
Okay, so I thought about this, and I've got 3 comparisons. I think this is one of the 4 most odd periods. I'd say it rivals with the 2015-16 winter precip, when we had that Godzilla El Nino. It wasn't.
Oh yeah.
It didn't actually. If you look at the data, it was sort of like average.
Oh yeah.
But we were just expecting just a monumentally wet season. So
that's in your mind. It blew your expectations because it didn't behave that way?
That's right.
Okay. Got it.
Yeah.
Okay.
I also think the 2005-2006 winter.
So bad.
Between the end of October and the beginning of March, the middle of March, 0 rain.
Yeah. Yeah. I had moved here in 2001, which I thought was as bad as it could get, and that was worse.
Right. It is the driest winter on record for the Tucson airport, going back to 1950. So El Nino, that didn't happen. The big El Nino of our lifetime.
Yep.
Didn't produce what we expected. Then there's this 2005-2006 winter that was just historically dry, and then 2017 July monsoon. That 3-week period.
Yeah, it's funny that I can't differentiate the 2017 monsoon from last year because we had such a good monsoon at our house last year. The season was so good that it erased all of my my 2017.
Wiped it out, huh?
It totally did. It was. I don't think this is, again, the monsoon becomes very personal. 2017 was like, yeah, it was cool. We had some awesome storms. You got great pictures. But last year, we were getting socked in at our house many times when you and Ben didn't see anything.
The monsoon is harder because, it is so spatially different that
across Tucson. Even.
Yeah, just across Tucson. Yeah. And with those 3, this May is ranks up there for me. Does
having this May and what we're seeing in June now make you more or less excited about the monsoon showing up?
Oh, that's a good one. It makes me less anticipated just because I don't feel the strain from the vicious sun that's usually there.
I'm with you, man.
Just the last couple of days, I was like cowering, in the shades. And normally you have like many more days of that prior to the monsoon. So you look forward to the clouds.
I feel like we've been eating out every night, and it's like the 6th night you're like, I don't care where we go.
Okay, so
does that make any sense?
It does, but I'm looking at the time.
He's not biting on this at all.
I just think maybe we should move on a little bit because I do want to hit on some of the impacts. There's still pretty decent snowpack across Utah and Colorado.
Pretty decent is a kind of underwhelming
understatement.
Understatement, I think.
Quite a bit at the mid to low elevations. Obviously, they're already melted out.
Fair enough.
And so
it is June.
It is June. That's a direct effect of the high country got some precipitation in May, and the cool conditions that were persistent west-wide.
Right.
Obviously, that matters for fire,
yeah,
and for drought conditions. I would point out this also: the drought monitor has the fewest area classified as drought across the U.S. as it's ever been
since it started in 1999-2000.
Yeah, if you look at the drought monitor over the last 12 months. Pretty much an improvement across many areas in the West. So
absolutely, yep.
It's a pretty good drought picture.
The drought monitor represents short-term conditions. So Lake Mead and Lake Powell, they're certainly looking better, and it's put shortage off a year or two. There's still sort of this sort of long-term, there's structural deficits, and there's still some catch-up there. But man, oh man, you want to break droughts, you do this. And if you want to break long-term droughts, you do this a couple years in a row. So let's keep it going.
Okay, and fire, this is our fire season, and I think we've got 4 big fires burning at the moment, some other ones as well that are I think 6 others. So in the Southwest, Arizona, New Mexico, currently there's 10 fires greater than 100 acres burning, but only 4 of them are like in full suppression. So the other 6 are being monitored. But I don't think the number of acres that have burned thus far in Arizona and New Mexico is close to an average.
I don't think it is either. The outlooks for the Southwest are below average for a lot of the higher elevation northern areas across Southwest. There is enhanced higher probability of above average fire activity in lower elevations due to all of the fine fuels. But if you rain on them, you keep humidity high, and the wind is down, then that definitely becomes less of an issue.
Humidity's been high.
Humidity has been high. And so we might end up having this sort of crunched season of low elevation fires that are a problem up until maybe mid-July. But other than that, we're really in a good spot as far as a lot of those impacts. And we've really cut the window of potential problems down to a matter of weeks now, and if monsoon onset is somewhere near climatology.
I think for fire, there's been a confluence of really favorable conditions with low temperatures, like some precipitation, persistent snowpack, good snowpack season. So it's looking pretty good from that vantage point. But that brings us to the monsoon, Mike. So what do you think?
It's only a couple days away.
Yeah. All right. What's your expectation?
Okay. So let me step back here. The National Weather Service, the forecast offices across the Southwest have agreed upon using June 15th through September 30th as the monsoon season, which I think makes some sense with respect to just sort of bracketing the season, expected impacts, communication, that kind of stuff. We used to use the dew point as a metric locally to establish if monsoon moisture has been at a level that be conducive of signaling.
It's perhaps a more objective way of
it's a little more mechanistic, I guess, or a little more
than picking a date.
Yeah, I mean, it's like hurricane season versus the actual hurricane occurring, but that's a discrete event. So this is a kind of a season. So it's a little bit of apples and oranges in that comparison. All right, so we're heading into the official calendar date monsoon season, but some of the outlooks issued by NOAA Climate Prediction Center, especially the week 3-4. So this is June 11th today we're looking at. So the end of the month into the beginning of July, the 1 month forecast all have a little bit of a hint of below average, which below average at that time of year when the climatology is low anyways, seems to be signaling a delay in the onset of the actual sort of slug of moisture that would be consistent with the dew point definition.
Yeah, there's actually been newspaper articles written that have people saying that, they're expecting a kind of a late onset.
Right.
And we should talk about what a late onset.
And so the dew point definition for Tucson, which is different than the definitions that have been used either by Phoenix.
Right. So that was part of one of the challenges of
a standardization.
Of the dew point. But nonetheless, historically, if you look at I think the median onset date.
Which is, and the onset is 3 days of daily average dew points
above 54 degrees.
54 degrees Fahrenheit.
Fahrenheit. So
throughout the day, the dew point actually varies quite a bit. It's high at night, low during the day. So the daily average would have to be high enough or higher than 54.
Right. So the average start dates then is around July 3rd. The earliest as June 17th, which one could debate about whether or not that was actually a rogue storm like it was last year.
Yeah, we should talk about last year.
But they have this. This data doesn't incorporate last year, and that was from 2000.
Yeah, and I'm not even sure last year would have triggered the dew point definition, which is interesting.
And then the latest on record is July 25th. Most of the year is sort of cluster around this July 3rd.
They cluster pretty tightly.
Like if you 70% of them maybe is within 7-8 days.
I know, which is amazing.
Right.
Amazing.
So when would it have started last year? If we didn't get that rogue storm on the 15th of June.
Yep. So we ended up having a fairly active weather pattern into June last year, not unlike we have this year. But we also had a Tropical Storm Bud. But it got caught up in this trough that was approaching from the west. Man, it was a perfect convergence of dynamics and moisture and a little bit of circulation from that tropical storm. It socked in all of southeast Arizona with heavy rain. And just across the Tucson area, we ended up having 1, 2, 3 inches of 24-hour precip there, right on the 15th into the 16th. After that, we went back to normal summer, And the monsoon in the proper sort of dew point definition didn't happen until about July 8th.
Yeah, so it would have been a late onset.
It would have been a late onset last year. Given the climatology for Tucson, and this varies, New Mexico, and then as you go further north, it gets later. New Mexico's earlier, northern Arizona's later. So we're kind of in between. I kind of always go back to that, right? We don't have a huge amount of deviations aside from that. So just having a week 3-4 forecast, which puts us into prior to the onset date for July, being below average, I kind of shrug.
Yeah.
I don't really care.
The reason people make a big deal about it is because, if you clip off just 1 week, you take off maybe 2 events. On average, there's, 25 rain events during the monsoon period, 100 days. So about every 4 days. And so if you take, 25 is not a lot.
It's not a lot for 108 days.
Yeah. So you take off 2 of those, then there is some correlation between a late onset and lower precipitation, obviously.
And we can have onsets where you hit these kind of faltered onsets where you hit the dew point and then it dries out and then you get 2 weeks of dry conditions. And then you start to really, stuff can get dicey really fast as you get into July. If you get some precip in the early part of the month with a normal onset, and then it falters and doesn't really kick in into August, you can have all sorts of ecosystem impacts to rangelands. You can fire up the fire season again.
Right.
What we're kind of looking at is both onset and then that consistency of that monsoon system setting in after that. And man, oh man, that is pretty unpredictable.
The fact that we get only 25 days of rain also sort of makes it very easy to change the statistics.
For sure. And if it rains at the airport or doesn't rain at the airport, then we start to get into those statistics of the spatial variability, which are enormous for monsoon type.
Yeah, that's
right?
true. And we'll do this in later, as we go through the monsoon season here, we'll sort of look at the spatial variability within the broader Southwest, but also within like these cities. Because
just in the Tucson Basin,
yeah, you can have quite a bit of variability. Okay, so we talked about the above average snowpack that we've seen this winter, and that still persists.
Yep.
And that there is this sort of idea of perhaps a later onset, and the CPC also is forecasting increased chances for below rain in June, July, and August.
Yeah, it's for the whole season.
Yeah.
I think that the below average is coming out of the onset in July. Since the start goes from no rain to rain, the variability onset correlates then with totals.
Right, and that's what I was saying. Yeah. There has been an idea, and I've seen it actually talked about in the news, cited in the news, that you have the snowpack, large snowpack in the mountains. That snowpack then prevents the land surface from heating up, which has this feedback that prevents the monsoon ridge from setting in and delays the onset. That was sort of ideas that were tossed around, 15 or so years ago, but is still sort of recirculated a little bit in some of the discussions that you see online.
10, 15 years ago, there was a series of studies that came back up. I think it had been looked at much earlier, had come back out in some analyses from some scientists across the West that had noticed in the statistics that in the Southwest, Arizona, New Mexico, and especially if you go down to specific sort of locations in Arizona, New Mexico, you can look at the statistics between the total amount of precip in the winter and the total amount of precip in the summer, and you see these positive correlations, or actually it's a negative correlation, right? So wet winters are followed by dry summers, dry winters are followed by wet summers. But if you really dig into the data, first off, the correlations are weak. They're not very high. They explain not a ton of the variance. And then there's some work that colleagues here at U of A had done with tree rings and reconstructing the monsoon back hundreds of years. They found this interesting result that relationship in the tree rings only showed up periodically, and it showed up most strongly, and again, not most strongly in the sense of for the whole record, but still not very strong in the sense of the pure correlation, only in the instrumental record. And so they're basically saying, well, this relationship is there. It's not very strong, just like everybody was seeing. So it doesn't explain a lot of variance, and it's not time stable.
Right.
So that would then suggest that it may be coincidental.
The Southwest monsoon is this large regional forcing pattern. When you zoom into, okay, we're talking about snowpack conditions in the high country of a really small area within this bigger bigger area. And you'd have to incite the influence of that small area to such a degree that it would affect the positioning and the timing of the monsoon ridge. And to me, it's like the subtropical high and all of these other forcings are they're much larger, and they would just swamp any sort of influence of snowpack. So I don't, to me, it's like a spatial scale thing. It never like resonated. The explanation never resonated.
Yeah, I think you're right. I think the idea of wet surface and snowpack across the West and its influence on land surface heating, meaning that if you dump that sun's energy into that surface that's wet, it's going to put mostly in evaporation. So it's going to be latent heating versus sensible. So it's going to then impact the boundary layer depth, which then translate into broader scale. It's probably over attributing that effect. So that is certainly part of it, but it's in
like a minor.
It's probably
maybe
minor.
A very minor
I mean, the
role.
The upper level circulation is tied to the hemispheric circulation, which is going to end up being noisy, especially in the winter, and then less so in the summer as we get further away from the wave patterns that typically are going to move through here and disrupt that ridge, which then the land surface heating becomes, I think, more important on position strength. Even then, it's still a hemispheric flow is going to be.
What about El Nino? Is it pulling the strings?
So it's been a weak event. It's been in concert with active Madden-Julian oscillations, which absolutely, I mean, they swing through the northern hemisphere and disrupt all the jet stream patterns. And so there's sort of background state of El Nino forcing atmosphere. There's MJO moving across it, and like I said earlier, constructively interfering with it, sort of enhancing its pattern, and then squashing it, and then working against it, and then all the other sort of upstream forcing that could be at play too. So
do you think then that the late air quote late onset is really in play here, or the default here is to sort of throw our hands up about the monsoon and be like, it's really unpredictable. The only thing that maybe we'd be able to say definitively is that it's going to be warmer than average. But in terms of other characteristics of the monsoon, frequency of rain events, intensity of rain events, onset, cessation, like all of those things, like it's really hard to find trends in those.
Sure.
Our default is like, we don't really know. We can't really predict. Or what do you think about the forecast for below for the early part of the monsoon?
So immediately, there's no activity in the East Pacific in the tropical storm. So that's the first thing I would look to right now. Nothing's going on. There's actually below average sea surface temps there for some reason. I don't know, something got stirred up in the East Pacific. The models over the next couple of weeks are suggesting that the East Pacific stays quiet. So that takes Bud situation off the table.
Which makes it so that we don't actually have to debate whether or not it's monsoon.
We don't, yeah. So it might make it a clean onset. Thankfully, yeah. So then, right, we don't have to have that argument. The ensemble forecast models for the northern hemispheric circulation across Southwest, they're really noisy, and they're really struggling to build a strong ridge in across the West and the Southwest. And they're even indicating that Mexico, which the progression of the monsoon is from north to south, is below average. These are multiple factors sort of stacking up on. But again, these are only out through like the 3rd to 4th week of June, which is not monsoon season anyways. And we've had plenty of years that have looked like that, and then it flips the first week of July, right? So it's almost like the onset at this time scale is kind of silly.
Right.
To probably even.
What do you mean at this time scale? Like this far in advance?
At months, certainly, it seems silly because we don't have a lot. We don't have good statistical empirical relationships. We don't have good dynamical forecasting. In 2 weeks, so the East Pacific fires up, and the persistence of the kind of noisy jet stream quiets down and lifts north. Then it puts us in a much better spot. There's this persistence element of this months of waviness could be noise that impacts the beginning of the summer. I'm going to go back to climatology. I'm not going to worry about anything. I'm going to worry about July 4th.
A dry start is no more in play than it would be in any other year. The CPC, the Climate Prediction Office, they forecast for the entire U.S. So really, and there's a whole bunch of unique climates across the U.S., obviously. Right. So they have a below an increased chances of blow conditions for basically the onset of the monsoon. So they see something there. The question to you is because we're pretty familiar with the intricacies of the monsoon, is that in play, or what do you make of that?
It depends on the forecast, and they'll be interesting to watch from CPC, Climate Prediction Center. They have these 6 to 10, 8 to 14, week 3, 4, and then month, and then seasonal. The week 3, 4 forecast discussion is not relying on this wet winter, dry summer week correlation. They're actually saying the models suggest that into the end of June, it's going to be quiet, right? So that's actually more climatology than anything. It's not drier than average. It just would suggest that you're not going to get activity that you might want to have at that point in time. The June, July, August seasonal forecast, the 3-month outlook, actually for just southern Arizona, there's an enhanced chance of it seeing below average in this June, July, August. That has invoked a little bit more of this, wet winter, dry summer. But they're also not saying the whole monsoon season is going to be dry. Right. They're just saying that they expect a little bit later onset. Climatologically, we don't have a ton of really lates. And as I talked about before, it's going to talk about consistency and spatial variability past that, which is way outside anything that I think we're able to do.
Right.
And they also invoke there still is a forecast of enhanced East-Pacific tropical storm activity.
That's right. And that's correlated with El Nino.
That's an El Nino forecast, which again is so funny because El Nino has been very weak and we have trouble really seeing it as a strong forcing mechanism. It's certainly been lurking in the background and maybe will continue to lurk in the background.
Okay. So with all of that, we do this every year.
Yep.
We have to do it again this year.
Okay.
We have to sort of rub Vaseline on our glasses and make some blurry-eyed guesses about
because that's what we do
with the monsoon. So let me go first.
All right, please do.
For Tucson, the climatology is 6.12 inches, and that's the June 15th through September 30th period. I think it's going to be slightly above average. I think it's going to be 110%, and so that would be 6.7 inches at the Tucson airport. Here's why I think that.
All right.
Based on what you said about the onset, I do actually think that maybe we're going to see a little bit less activity in the beginning. We have to throw our hands up about what the middle is going to do. And I'm just going to default to climatology because, you don't know, okay, so how many Gulf surges are there going to be? How many low pressure systems are going to rush past the outlet of the Gulf of California?
Yeah. What's
the sort of upper level dynamics going to be? Is the wind profile going to be right to organize storms? Are you going to have these inverted troughs that come across? I mean, all of these things are at play for the monsoon season that some of them are probably random. I'm just going to say I have no idea what's going to happen during the middle. But I'm going to say it's above average because of what you just mentioned before, which is there is an increased chance of tropical storm activity in the East Pacific.
You're going to be so sad when all this comes in October and totally misses September,
and so I think we have elevated chances for one or two sort of September late monsoon storms. And hey, listen, you just need one of those, and all of a sudden you go from 70% of average to 110%. So boom, that's my forecast. 110% of average. What do you got?
6.1.
6.1. Oh, that's the number you said at the beginning.
Yeah, I want climatology. I'm going climatology. I feel like the East Pacific forecast, I'm not sure that's going to hang in there, and I'm not convinced.
Why don't you think it's going to hang in there? Do you think El Nino is going to fizzle?
Well, it never really sizzled. So it's I guess it's been the East Pacific is a bit cooler than it was last year, which I feel like was a much bigger driver of it, and which was maybe not even El Nino related. I'm not convinced on the late onset. I feel like there's a lot of noise and a lot of opportunities, possibilities. But man, I feel like it could break either way. So all of my pluses and minuses averaged out to climatology. Isn't that sad? Ben actually is super pessimistic.
Yeah, Ben goes at, he is pessimistic. So he goes at 4.6 inches, which is 75% of average.
So 2013, we had 3.74 inches at the airport. So that would be the closest bad year. Because we've had a run of 2014 was 6.08, 2015, 6.63.
That's true. We're kind of due.
So we've had a 5-year run of average to above average. I'm hoping we can hold the line. Mexico.
So Ben just slacked this. This is a monsoon proper forecast.
Monsoon proper.
July, August, September.
Yeah, it's below average. The skill score on this is terrible too. So I would just throw this one out.
The CPC calls it equal chances.
Equal chances. Yeah. I feel a little more optimistic than a full crater here. But this is bothersome for me. The Mexico is forecast to be below average with some of these seasonal forecasts.
Well, that's a harbinger, right? Like looking at the Sierra Madre, which is
south.
where the core of the monsoon is.
Yeah.
Okay. So wait, we got one more thing to do.
We got one more thing.
And this is something new. And I'm really excited about this. So this is our new monsoon fantasy. If people play fantasy sports, we're doing this game this year where across Arizona, New Mexico, each 30-day period, so the beginning of the monsoon, June 15th to July 15th, we each get to pick 3 stations. And we add up the percent of average for each of those 3 stations. And whoever has the highest average, equally weighted, wins.
So the total percent above average is the score.
Okay, the total works too.
Yeah.
Or
let's total it up. I don't want to average it.
Yeah, we'll total it. In your 3 stations, it's 110, 110, and 110. Your total is 330.
Yeah.
Okay.
And if it's 50-50-50, you cry. Yes.
Okay, so we have a map of all of the stations that we're looking at that we have long-term records for across the West. And so for the first 30 days, and we did a snake draft before we came on here. So Mike, why don't you start? What do you got? What are your 3 stations?
June 15th through July 15th, I chose Douglas, Gila Hot Springs in New Mexico, National Monument, and Nogales.
Okay, so Douglas it's
along the border, southern Arizona.
Gila Hot Springs is where?
Up in the Gila National Forest.
In New Mexico.
And then Nogales. So I stuck south and a little bit east to try to grab the higher elevation. Well, actually, Douglas and Nogales are not higher elevation. Some more consistent early monsoon places.
Why did you do Gila Hot Springs?
Upper elevation.
Upper elevations.
Yeah.
So
it's going to be tougher because its average is higher. So it needs to rain a lot there early on. But New Mexico has actually been off to the races with quite a bit of precip. So I'm feeling pretty.
And you were saying this before, New Mexico has a slightly earlier onset than. Now that 2-week forecast that has sort of quiet period, does that also have a quiet period for?
No, New Mexico's been in the action. It's been raining there.
And Nogales, so why Douglas, which is a little bit to the 100 miles east of
I'm just
Nogales?
playing climatology of where the precip will be in the next 30 days, and it will be south of here, hopefully, ideally.
Douglas and Nogales are both low elevation deserts.
Yeah, but we can get those really great border storms that go from east to west, and you get these overnight storms that blow up along the border on outflows from the Sierra Madres.
And those are the MCSs, the mesoscale convective systems. Now, do those actually tend to waft into New Mexico at all, or are they more southern Arizona kind of thing?
Southern Arizona.
Those can actually generate quite a bit of rainfall. So my 3 is I'm going Kip Peak, southern Arizona, south of Tucson. I'm going Tucson because, hey, I'm a homer, and I might as well be rooting for my backyard. Plus, it's close to where I live.
Apparently so, yeah.
And I'm going, and here's my outlier. I'm going Oregon Pipe, which is basically half on the border of Mexico, halfway between Nogales and California border. Oregon Pipe gets just not that much rain at all. They get like less than half an inch. But hey, if it just gets one storm, that's my haymaker. Okay, so last year, for example, before July 15th, had close to a little over 2 inches.
That was last year.
Yeah, that was last year. So boom, that would have been 300% of Kip Peak is my high elevation.
Yeah.
Yeah, that's my ringer. But oddly enough, it actually only gets on average about 2 inches of rain for that first month. But hey, if there's enough moisture around and the winds aren't great, I got a solid.
I think the high elevation stations are good solid bets. Yeah. The problem is they've got to perform above average.
So last year, Kip Peak got close to 4 inches. So that just would have been 200% of average. So Oregon Pipe did better.
Sure, whatever.
You're not impressed.
No, I'm not impressed.
I spent a lot of time thinking about this.
I know you did. I know. Yep. I'd say a Yuma. I want to see a Yuma thrown in for some real gutsy play.
All right.
I might think about Yuma in September.
We'll probably end up moving north as in next month. It's not useful to pick northern stations right now.
Probably not. Not yet.
All right, everybody. Thanks for tuning in, and we'll be back in a month. And
happy monsoon season, everybody.
Happy monsoon.
I think that's it. That's the 2-hour podcast, pre-monsoon podcast.
Yep. We could talk about a lot more too.
Was this time for our sponsor?
We have a sponsor?
No, we don't.
We need a sponsor. Whoever's out there listening to us, we really need a sponsor. And consequently, Mike and I cram at the last minute.
You crammed. I didn't even bother cramming.
Yeah, but you pay attention to this like baseball.